Welcome everyone, and the title of my presentation is Implementation of Mathematical the Modelings for the Non-Mathematics the Majors. And I'm W.Y. Chen from Texas A&M, the University in Texarkana. In my presentation, I cover the following is what courses cover the mathematical, the modeling, the ideas in our institute, and also about the background of the student of in our modeling the class, what topics we covered in this modeling the class, what kind of the interdisciplinary the project we give it to our students. So this is the first part. And the courses in our university, we had the modeling. The idea is kind of diverse. Our differential equations, the class, and needless to say is our modeling, the classes, that is in the 400 level, the classes. And this semester, I'm teaching the probability and statistics. And we also have some problem solving the idea of the word problem. So student will also use the idea and then on the modeling and in these courses. And the calculus and the college algebra, we introduce the word problem and the story, the problem to our student. So pretty much they touch a little bit based on the modeling, but not kind of formal. Differential equation, we finished the we are in the middle of the first order differential equation. So we introduced several of the mathematical the model, especially the first order, the differential equations to our students. And the size of the class is around 6 to 20. So we are in a small institute, so we don't have a lot of the student in each class. And then the modeling, the class is ranging from 4 to 10 students. So that is the range I have, all right? My colleague has almost the same. So we have 2 people, we share the load. And the probability and statistics, this semester, I'm going to 5 only, but the calculus and the college algebra, we can go up to 30 students. So it's a kind of diverse right there. And next topic is the next section is about the backgrounds of the student in the course of our mathematical, the modeling, the class. Our mathematical, the modeling is one of the required course of in the math major. And I would like to highlight in here also is the math education and electrical engineering. In fact, we have the mechanical engineering as well. They also need these the modeling, the classes, and the computer science. So their background is a kind of varied. And the math and the engineering, they have a kind of similar, but the computer science, then it will be different. And they only have Cal 2 only. So up to Cal 2, then they do not need any kind of the math the classes. So what we introduce in our modeling the class is we sing about the discrete model. And then this one is mainly on the difference equations. And we cover the continuous model, that is the differential equations, the part that is the second, almost the second portion of this modeling the class. Then we say that. But we introduce a lot of the applications to our students. So to keep the class academically challenged and enjoyable, and some students, and we also assign the projects and the class, the problems and the discussions as well. Student will also have the the class, the presentation, and then the face-to-face or the Zoom, and then in the class, so that they will help the student to understand the principle and the methods. All right. So we have someone is to raise the hand.
Hello.
Sorry.
Thanks for your talk so far. I'm just curious, what text do you use for the modeling course? Because I saw that you listed your text for differential equations.
Sorry, okay, I missed you. Okay, the textbook, yes, it's a good question. This is the one. A first course in the mathematical, the modeling. That one is by the this is the cover. I forget the name of that one, but this is right there.
Thank you.
Right, thank you. And we also encourage the creative, the idea, and students, they also have the flexibility and when they work on the projects. So I mean the flexibility is they can set up any kind of the mathematical, the equation. They don't have to be in the differential equations, the model. So they could be the non-linear, the non-differential equations, the type. It can be the discrete the model or using the computer the model like that, using the spreadsheets. So the topics I covered is the first one is definitely the procedure. How do they construct the mathematical the model? So they have the real world, the behavior, and then set up their own model and solving that. So then they will get the mathematical, the conclusion, and compare the conclusion to the real world, the conclusions. So difference equation, so we say that, or we have this system of the difference equation. And they could using the numerical, the method, and then to compare the result. And the model can be linear and then the non-linear, the model. So we have a lot of the diversity provided for students and then on the thinking. So it's not limited only on the differential equation. So this is the diagram. We always refer to our differential equations, the class, and also the modeling, the class. But this idea is quite similar to the problem solving the skill. You see that we identify the problem and then you explore and also the creative or the create some idea. You have a lot of the ideas right there and then you select the best one and to build up your model. So once you build up the model, then you're going to test your model. Is it working or not working? So we let the student to try it. So this idea is also similar to the data, the mining, the process. Understand the business and also the data. You have a lot of the data right there, but you don't have to use every single one. Some will be eliminated before you build your model and then you test that. So different aspect or different discipline, then we also have the similar the idea. And this is the equation or the data point. Students, they really like the scatter point in the X, Y, the plane. So the data point comes from the textbook. So Nathan, you asked me these questions and then before. So this is the data point we provide to the student. So so that provide them for the first thought. So student will measure about the rise of the data point. So they will imagine that, pretty much this one looks like a straight line, the model, but we are saying about the growth of the yeast. So about the mass. So you look at the trend of the number, based on that one, it looks like similar. And then to a straight line. But the time horizon we have is from 0 to 7 hours. But if we go further on the time horizon, then the problem, the nature will be changing. So the data point is no longer a straight line anymore. It could be a nonlinear function or a logistic equation. Then the student will begin to change their idea in their thinking. So what should we do? How do we adjust our equation to fit into this kind of the scenario? So this is the way how do we start and then to on a discussion in the class. So this is different kind of the model, and then we say that mortgage, population is the one, later on I will say it, and then the traveler, the tendency. So we have different hubs of the airport in here. So how do the traveler, they switching to one airline to another airline? So it could be a system of the difference equations. And students will also learn how to fit the model, finding the parameter of the model using different kind of the method. And the other application is not only on the population, the growth, how about prescribing the drug and the breaking the distance of the vehicle and so on. So there are some examples we introduced it to our class. And student, okay, because some of them, okay, they are the computer science, the major, they really like to using the spreadsheets to estimate the number. It will give them the fast and then the quick and a look what it will be the parameter looks like. So they do some data analysis using the Excel, the spreadsheets, or the online, the software. In the future, we would like to have the implement the Python on the MATLAB. So these couple of the times we don't have the time to say this one. We have a lot of the topics we want to talk to our students. So what assumption they should write down in their model? Are they reasonable? Student can put down maybe 10 or 20 the assumptions when they build their model. But do they use all these models, or are they all reasonable? So that one will be an issue. So this is some resources we have. And then the next part is about the interdiscipline, the project, we say that. So there is the one I referred to. We have 2 students, we have 4 students, they register in the class in the spring 2021. And 3 of them, they are the computer science, the major, and 1 student is a math education, and he graduated already. Now he is teaching in a local, the high school, and each student, they will have 2 projects to do. And one is an individual the project, and the other one is the team project. And how do we prepare our student to solve the model or prepare the model is working on their own model is we have to explain and the procedure, and then just like the diagram, we say that to them. And how do they write the report? What do they need, all right? And we encourage the student to put the graph and a diagram in their report and prepare their PowerPoint slide. And using the Microsoft, the Microsoft Word or the LaTeX, and then to prepare their report and incorporate their Excel, their spreadsheets, and also their computations. And make sure that they print their name and also which problem they're solving. All right, so sometimes they're too excited, they forget to print their name or forget to put down the problem they're solving. We also encourage the student, and then if they have their short video, and then I limit them for the 5 minutes, and then they can incorporate that, put this one in their PowerPoint. And so far I have a team, okay, 1 team is they did this one, and I give some bonus the point for my student if they do it like that. So they would like to produce some kind of the video and put this one into their presentation. About some project I would like to share with our session, with this section is the individual the project. So that one is from the COMAP. So that is kind of the long history, the problem, and then about the safety of the stuntman. So mainly the project is a stuntman on a motorcycle, the team, and then they jump on an elephant and land on a pile of the cardboard. So the main job is to protect the stuntman, the safety. But we would like to using a lower cost and then the no scene, okay, by the camera like that. So this is their main job they do. And this is some of the requirement I would like my student to do that. So mainly is from the description, and I do not have any changing what kind of the size of the box and how many boxes they need and how do they stack up the box and so on. Here, I would like to share some of my students, the model. So this student compare 3 stuntmen. So one is a lady. And they compare their height and also their weight and also the distance they travel. So some can go up even to the 351 feet. So they found this number information from the internet and so on. So there are a lot of the factors right there. And when they build their model, so they're using some kinetic energy and the potential energy to problem and then to solve that. You will see that their model is the non-linear model, but it is non-differential the equations the type. And this one is about the linear model. So this is some sort of the submodel they're using. And the other one is about the population of the insect and also the natural, the predator, the beetles. So I just put down some kind of the summary in here so that the insect and then the beetles. So one is a predator, the other one is a prey. And however, I put something is interesting is, how about if we have some insecticides and then in the environment? So what will happen of your model? So this is do some kind of the changing and alternation. So students will find this one is they have a lot of the things they can do, right? So they build up their different equations, the model, and how do they interact, the insects and the ladybug and the beetles and so on. And the other one is the following, the 2 is from the COMAP, the ICM, the model. And the first one is we want to keep the pace about the changing of the environment. This one is about the environment and economics, the changing and the consumer starting to migrate to the electric, the vehicles. Our country is going into this kind of the direction. So in the US and also the country is going to release the effort to release and the affordability of the all electric. This one is the Tesla, the model number 3. And the other country, just like the China and so on, they also say that they ban the gasoline and also the diesel, okay, the diesel, the cars in the coming years. So based on this kind of the challenge, and then what will be the team, okay, in helping to determine the final, the architecture. You know that this electric car, they need a lot of the charging the station and the charging the network. So they're going to help, how do they build this kind of the charging the station? And I modified the questions a little bit because we are in Texas. So one of the switching of the problem is if everyone's switching in the all electric, the personal, the passenger, the vehicle in Texas, and how many charging station, okay, we need in here, or super the charging. They have the super the charger as well. So this one you can charge within 30 minutes instead of a long time, 12 hours like that, so that you can keep your car running and so on. The area could be urban and suburban, the area, or the rural, the area. So this one gives a lot of the challenge, okay, for my student. And one example I would like my student to do if they want to do the urban, the area is on Dallas, the region. And then the other one is also from the ICM, the problem. So this is accessible in the code map and then the website. And the effect of the climate change, and including the droughts and then the glacier shrinking and the changing of the animal and the plant and the range, and also the sea level, the rise, and already realized it, and from region to region. Many of these kind of the effect will alter the way of the human, the life, may also have the potential to cause and the weakening, the breakdown of the social and also the governmental destruction. Consequently, we have the stability of the government could result in the fragile the country. So this is mainly about the problem, the nature they stated from the ICM, the problem. And then I also change a little bit in here is in the question number 2. So how about in our US? And I provide the information of the 10 the most the fragile the state in the US. Can they using this kind of the information to determine the climate change may increase the fragility of this state? So they can select the state they want to investigate and then to do their model. So the following is my student, their work. So they create some kind of the variable over there, and they also have a linear model. So this is the main linear model. And then they also have the sublinear model right there. So this group is using the linear equation, the idea to solve it. So you see both of these 2 assignments right there on the project. They do not use any differential equations, but they present it pretty nice, okay, in the presentation in the group. And so they focus on building the model and solving the model and draw the conclusion. So this is what they did. And some kind of the problem I find out in this for the student project is student, they only have a little and no background about the model. So about the loop, I say that they don't have any idea. And so you need to train them and give them some kind of the input. And they do not know how to write down the assumption and also the reasonable assumption. They can give you a lot, but are they all useful? And when they see the problem, then they will just maybe hold on, and then they do not know how to answer. I mean, they do not know to handle it right away. You give the time, and then they could give some solution and different kind of the thinking, or they need some kind of extra the helping. They have a little the experience to write a report or proper the PowerPoint the slide. And they also need a lot of the practice on their presentation as well. So this is some sort of the sharing I have for these sections. Do you have any questions for me? Anyone?
I guess I have one question, if you don't mind.
Yes, please.
So you said one of the struggles that you have is just inducting the students into the modeling process, right? And it seems from what you were saying, it sounds like that the students have difficulties at pretty much every step of the process. Do you have like a heuristic way, or did you have any resource that you use to help them overcome those challenges?
The resources is a good question as well. And the one, okay, on the website, the link I put down right there. Let me go back. And the email, and then the resources over there, and they have the resources, okay, that we can use, and then to help our student. How do we coach our students? And then the textbook is also a good one as well. So we start with some sort of the basic, the idea of the linear equation. So they have the common, the background, they know it. And then we build on this one and then go to the nonlinear equation. But about the modeling, the process, for example, about the real world, the behavior, how do we collect the information? How do we give them, and then the number? So the textbook provides some, and the other textbook, you know that on differential equations, the book, they don't have a lot, but this one, they have the data point they can provide for us, and then to help us for the
I think our next
I think it's probably time to be done.
be
Yeah.
starting up now.
Yeah.
So
yeah.
Thank you.
we'll have to cut the
Nathan,
questions
I can share, okay, the name of the book for you, okay, and send this one.
If you could just type it in the chat, that would be helpful. Thank you.
Sorry.